because they are easy, but because they are hard.
I grew up during the 60s when it was Mercury, it was Gemini, it was Apollo. Every month, NASA was doing something more impressive than in the month before. We were going to be on the moon by 1970, Mars by 1980, Saturn by 1990, Alpha Centauri by the year 2000. We were moving out, and I wanted to be part of that. And so I got myself a scientific education. But then in the early 70s, it's all collapsed. We achieved the first part of that program, Moon by 1970, but the Nixon administration shut down the rest, and we did not move out into space. And for a while, I accepted that, grudgingly. I became a science teacher. But then in the early 80s, something hit me, and I said, I'm not going to accept myself doing less than what I had dreamed of doing when I was a boy.
Zubrin went back to graduate school, getting advanced degrees in engineering and aerospace. He then went on to work at Martin Marietta, which later became Lockheed Martin, designing interplanetary missions. It was here that Zubrin's obsession with the Red Planet began to take hold. While at Martin in the 1990s, Zubrin and his colleagues developed a plan for sending humans to Mars that changed NASA's thinking on the issue. But the plan has languished on the drawing boards ever since. Now, as president of the Mars Society, Zubrin is at center stage in the debate over the future of manned spaceflight. Known as a smart, visionary scientist, he has authored several books on exploring space and is the self-appointed spokesman for the possibility of colonizing Mars.
Mars is where the future is. Mars is the closest planet to the Earth that has on it all the resources needed to support life and therefore technological civilization. It has water, it has carbon, it has nitrogen, it has a 24-hour day, it has a complex geological history that has created mineral ore, it has sources of geothermal energy. Mars is a place we can settle.
One reason for such optimism over a frozen world like Mars is evidence that 2 billion years ago, Mars was a much warmer and wetter place.
We think that at one time in the ancient past, Mars was very similar to the condition of early Earth.
This Martian warm age lasted for over 1 billion years and could have been a suitable environment for the development of life.
If we go to Mars and find evidence of a second genesis on Mars, I think we can conclude that the universe is full of life. We can probably conclude that on some planets that life evolves to more complex forms, and I think we'd be reasonable to conclude that intelligence could also emerge on some planets as well. It really does answer the question, are we alone? And that to me is a question that transcends science. It's a philosophical, societal, as well as scientific question. To me, that's the big prize. That's why Mars is interesting. That's why human exploration makes sense.
Space programs are often criticized for the huge sums of money they require. Although the American space program is less than 1% of the federal budget, a human mission to Mars may have to wait for better times.
There are those who say that we have many problems to deal with here on Earth, and we need to postpone ventures such as the human exploration on Mars until these problems are solved. Well, there were many problems in Spain in 1492, and there still are. There are problems that need to be dealt with here on Earth and should be dealt with. But we also have to think of the future. We also have to think about opening up new volumes in human history. I believe that it's essential for a positive human future that humanity expand into space. The greatest value that we got out of Apollo was the creation of intellectual capital through the inspiring of millions to go into science and engineering to be part of the great adventure of human expansion into space.
There's a phrase that happened with the Apollo program, which was, if we can go to the moon, we can. And then everybody's filled in whatever they were interested in. Build mass transit, cure cancer, do this, do that. The point is, it did give us a sense that we could accomplish great things. It did bring out the best of us.
We excited a generation of engineers and scientists. The generation that built the computers and cell phones and all the technology everybody uses today and takes for granted.
If we set humans to Mars as our goal, we'll get millions of new scientists that will create new inventions, new industries. This is the enormous payback, and we can get it if we set the kind of challenge that will inspire the youth.
To Zubrin, civilizations, like people, thrive on challenge and decay without it.
We have everything we have today because of our predecessors who had the courage to leave the world of the known and go out into the wilderness and build new cities. And if we stop being people like that, then we will hand down much less to our posterity than our ancestors handed down to us. So there's the choice in life. One either grows or one decays. Grow or die. I think we should grow.
History proves that we have never lost by pressing the limits of our frontier.
In the summer of 1989, the first President Bush announced the Space Exploration Initiative, directing NASA to draw up long-term plans to get humans back to the moon and begin developing a program of manned Mars exploration. At Martin Marietta, Zubrin and his colleagues looked forward to moving NASA's space program outwards after 2 decades in low Earth orbit.
Of course, we were very excited when Bush made his call saying that he was making a national commitment to implement such a program.
NASA assembled a large team to take on the space initiative. In 90 days, the team developed a 30-year plan that required an enormous buildup of space infrastructure.
What the NASA bureaucracy decided to do was basically design the most complex mission they possibly could in order to make sure that everyone's pet technology would remain mission critical, which is the exact opposite of the correct way to do engineering.
First, NASA would triple the size of the planned space station and add enormous hangars, as well as free-floating fuel depots, checkout docks, and cruise stations. Then, on the moon, they would construct more shipbuilding facilities, bases, and depots. Next, the moon crew would construct the Mars ship, a huge craft dubbed by its detractors as Battlestar Galactica. This ship would carry everything to Mars over an 18-month flight. Once in Mars orbit, a small group would descend to the surface, spend a few days, then plant a flag in the ground and go home. The plan became known as the 90-day report.
To those of us at Martin who had been engaged in designing Mars missions, when they saw the monstrosity of complexity of the 90-day report, we were dismayed, and it was readily apparent to anyone with any insight that that program would fail politically.
The plan was submitted to Congress. The estimated cost, $450 billion. The legislators went into sticker shock. This would have been the single most expensive program for the United States since World War II. By the end of 1990, Congress had refused all requests for SEI funding. When the realization came that SEI was doomed, Zubrin wrote a memo to his colleagues at Martin Marietta, outlining his problems with the NASA plan and arguing for a more direct approach. Zubrin favored launching a Mars mission directly from the surface of Earth, using only existing rocket technology. This negated the need for a lunar base and avoided the complexity and cost of building ships in space. He also objected to NASA's plan for a short surface stay on Mars, a mission that would amount to little more than a flag and footprints exercise. To Zubrin, we were going to Mars to explore and develop a new world. To maximize surface time, Zubrin proposed using a faster flight path, known as a conjunction-class mission. This would mean a crew could arrive on Mars after only a 6-month journey. They would then remain on the Martian surface for a year and a half. This would give the team time to explore a wide area and conduct detailed research about the planet. Then, as the Earth return window opens, the crew would launch